We're going to divide polynomials today. So we're going to go back and think about how we learned how to divide in elementary school. Is 5 a factor of 115? And how do I know? Well, let's see. If I take 115 and divide by 5, what do I get? 5 goes into 11 twice. Bring down the 5. There's no remainder. Yes, and how do I know? It has a remainder of 0. Is 7 a factor? Well, let's try it. Let's divide 7 into 115. It's once, subtract 7. Ooh, let's see. This one has a remainder of 3. So I'm going to say no, it's not a factor because the remainder is 3. So we're going to do some dividing today. So let's think about what we did. In our first step, we divided 5 into 11. So number 1, we're going to do division. And we said 5 goes into 11 twice. 2 times 5 is 10. So my second step was to multiply. And then I subtracted the 10 from 11. And then I brought down the next term. And if there were more numbers, I would just repeat this process. So we're going to use this as a guideline for our steps because we're going to divide polynomials. So I'm going to take x squared minus 6 and divide it into x to the third minus 10x squared plus 19x plus 30. So the first thing I do is I divide x squared into x to the third. What do I need to multiply times x squared to get to x to the third? And that would be x. The second step, we're going to multiply the number on the top times the side. Basically, remember, we're going to distribute. So don't just multiply the first term, multiply x times both of those. X times x squared is x to the third. X times negative 6 is negative 6x. Now notice I put the 6x underneath the other x term. There's no x squared term here. So if you want to put a 0 there, you could, or you could just leave it blank. Now my third step said to subtract. When I subtract a polynomial, I just change the signs. So subtracting x to the third, subtracting negative 6x is actually a plus. So x to the third minus x to the third should cancel. The negative 10x squared just comes straight down. 19x plus 6 is 25x. And I'm going to bring down my plus 30. So we go through the division process again. What times x squared would give me negative 10x squared? I'm going with negative 10. So I'm going to distribute negative 10 times everything over here. Negative 10x squared plus 60. Then we subtract. So we change these signs to a plus 10 and a negative 60. So minus 10x squared plus 10x squared cancels. I get 25x, and 30 minus 60 is negative 30. This is my remainder. So in Advanced Algebra 2, we are going to write the remainder as a fraction. We're going to write the remainder as 25x minus 30 over my divisor, x squared minus 6. So for example, up here, when we divided 115 by 7, we said it was 16, remainder 3. Another way to write that would be 16 and 3/7, your remainder over your divisor. And that's how we're going to write it. So if we asked, is x squared minus 6 a factor of this polynomial? We'd say nope. It has a remainder that's not 0. All right, let's try it again because this process just takes practice. And you do have to be very careful with your signs. Let's try this one. I've got x plus 3. Then I've got x to the third. I don't have any x squared. So you know what? I'm going to just leave a space for x squared. You'll thank me later. So 0x squareds minus 4x plus 6. Okay, so we start our process. We're going to divide x to the third divided by x, and that gives me x squared. And now we're going to distribute x squared times x squared times 3. Our next step was to subtract. Change those signs. X to the third minus x to the third is supposed to cancel. And this is negative 3x squared. Bring down the negative 4. And we start the process again. What is negative 3x squared divided by x? Well, that's negative 3x. So now we distribute. Negative 3x times x is negative 3x squared. Negative 3x times 3 is negative 9x. And now we subtract. So when we subtract negative 3, it's plus. When we subtract negative 9, it's plus. The subtraction step, you just change all the signs. Negative 3x squared plus 3x squared cancels. This gives me 5x. Bring down the 6. So now we divide 5x divided by x and get plus 5. Distribute 5x plus 15. And now we're going to subtract. And we get negative 9 for our remainder. So my solution to this, my quotient just means the answer to a division problem. Negative 9 over x plus 3. That's how I'm going to write my remainder. And yes, you could have written your remainder as minus 9 over x plus 3. I don't use this way often because if there was more than one term on this numerator, that minus would distribute to those and kind of mess things up. So I just always put a plus and then my remainder over my divisor. All right, let's do another one. Determine the quotient. I've got 2x minus 3 and then 4x to the fourth. There's no x cubes. 5x squared minus 7x plus 9. So you want your powers 4, 3, 2, 1, 0. It'll make it so much easier because if you forget that, you have no spot for x to the third. So we divide 4x to the fourth divided by 2x. That gives me 2x to the third. Distribute. And that was 4x to the fourth. Now my subtraction gives me 6x to the third. Bring down the 5x squared. Now I divide 3x squared. Now I distribute minus 9x squared. Subtraction. Oh, that's a 14 now. Now I divide. This looks like 7x. 14x squared minus 21x. Now we're going to subtract. Negative 7 plus 21x is 14x. Bring down the 9. So this is a 7. And then I'm just going to write it up here so I have space. 14x minus 21. So my final subtraction is a remainder of 30. So for my remainder, I'll put plus 30 over 2x minus 3. So division just takes practice of repeating this process of divide, distribute, subtract, and bring down. Here's an interesting question. It says, determine whether 2x plus 1 is a factor. All right. Well, we know that one way to do that is to do a division problem. If the remainder is 0, the answer is yes. So let's try this. Let's try dividing by 2x plus 1 into 2x to the third plus 3x squared plus 7x plus 5. All right, so the first step, divide. 2x to the third divided by 2x is x squared. Distribute. And now we're going to subtract and bring down. Let's divide again. 2x squared divided by 2x is x. And now I distribute. 2x squared plus x. Subtract. And I get 6x plus 5. So I brought down the 5. Now we divide. 6x divided by 2x is 3. Distribute and subtract. My remainder is 2. Is f of x, or is m of x, 2x plus 1, a factor of f? That's a j, not an f. So my answer is no, because it has a remainder of 2. The remainder has to be 0 for it to be a factor. The next question is a little bit easier to answer. On this graph, can you identify the zeros? I see a 0 at -2. I see a 0, I'm going to say that's at 1/2. And I see a 0 at 3. So if I were to write those as factors, this would be x plus 2. I'm going to blow your mind here. 1/2 is actually from 2x minus 1. Because if I set 2x minus 1 equal to 0, I would get 1/2. And the 3 comes from a factor of x minus 3. Is 2x plus 1 one of these factors? No. Because if it were, x equals -1/2 would be a 0. All right. Some good practice on long division.